Okay, welcome to video 12.3, Interpreting Variation of Data Using Standard Deviation. So our measures of central tendency give us numbers that describe the typical data value in a given data set, but they do not let us know how much variation there is in the data set. So two data sets can have the same mean, but look radically different depending on how spread out or varied the numbers are in the sets. As we've previously discussed, the interquartile range gives a good idea of the spread of data, but the best measure of variation within a data set is the standard deviation. This is also found using our calculator. So standard deviation, which is this SX in your calculator, tells us on average how far a data point is away from the mean of the data set. The larger the standard deviation, the more variation within the data set. The smaller the standard deviation, the less variation within the data set. So when using standard deviation, you will always need the mean. Okay, so let's see how we use and interpret the standard deviation. In this exercise, we're going to look at the farm with the baby chicks and how much they weighed after 1 week of growth, and we're going to find the mean, median, and standard deviation by going to our calculators again like we have already been doing. We're going to put all of our data into L1, so you do that by going to Stat, Edit, clear anything that's in your list by going up, clear, down, and then you can enter in the 2, 1, 3, and so on until you have that entire list in your L1. Then you're going to go ahead and find the mean, which is X bar, median, MED, in the calculator, and standard deviation, which is SX, for the data set, rounding to the nearest tenth. So when we go to our calculator and we look at the mean, median, and standard deviation, the mean is right at the top. The median we have to scroll down to find, and then the standard deviation, if you scroll down, you have to scroll back up to find that in the calculator. And then we get these values, 3.7, 3.5, and 1.8. So what I'm going to do first is represent this information as a dot plot, as we've already done and seen in the previous video. So I'm going to go ahead and label my X and put a title on the dot plot. So I can see here that I have all of my data represented as a dot plot, and I have a title and the numbers so that I know what everything represents. Now we have the bell curve to the right of that, and this is showing us that we can write the mean in the middle here. Then we would have a standard deviation tells us how much it deviates away from the mean. So in other words, most of the data will fall within this range here. So I would go up 1 standard deviation by taking 3.7 and adding the standard deviation, which is 1.8, to get the 5.5, and then subtract 1.8 from 3.7 to get 1.9. So that would show me that the data, a bulk of the data, falls between 1.9 and 5.5. But not all bell-shaped curves are symmetrical. They can be skewed with a tail, but we still use the mean and standard deviation to create the boundaries. And this will be explored more in Algebra 2 and AP Statistics. The next question says, how many data values fall above 1 standard deviation above the mean? So I'm looking for, if we have the 3.7 above 1 standard deviation above the mean, that would mean we need to add 1.8 to that 5.5. That's 1 standard deviation above the mean. So how many fall above 1 standard deviation? So if I look back, that means that we're looking for above 5.5. So greater than 5.5, that would be here. So that would be our 6, so 2, and then 8, 1. So 3 data values fall above the 1 standard deviation above the mean. And the next question says, what percent of the data falls within 1 standard deviation of the mean? Well, now within 1 standard deviation, that means they can either be in anywhere in this bell curve that we showed here. So anywhere here from 1.9 to 5.5 is going to be within 1 standard deviation. So basically we're looking for how many of the values fall between 1.9, which is really going to be really close to 2. So starting at 2, up to 5.5, so only up to 5. So how many fall between 2 and 5? So we just have to count the dots. 1, 2, 3, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 data values fall in that area, but the question asked for the percent of data values. So 15 out of the 20 is 0.75, meaning 75% of the data values. Okay, that's it for this video. See you tomorrow.